Welcome back to our set of videos on Kenyan farmers' responses to climate change. Contingent behavior surveys hinges on two important information: hypothetical future climate conditions that should be clear and meaningful to farmers, and realistic adaptation strategies. To develop these future climatic conditions and strategies, we need to integrate scientific research with farmers' first-hand knowledge and perceptions. In this video, we present the methods used to develop these crucial elements. To capture the diversity of farmers' views, we organize focus group meetings. These sessions were designed as brainstorming events to gather both qualitative and quantitative information. The discussions were structured into 5 phases. In phase 1, participants introduced themselves, sharing information about themselves, their farms, and discussing activities with the group. In phase 2, participants were asked to reflect on significant changes that have occurred on their farm over recent decades. They noted these changes on stickers, which were placed on the board. Similar changes were grouped together and labeled, fostering a mutual understanding. Typically, each session highlighted 4 to 6 major climate-related changes. In phase 3, participants then ranked these changes based on 4 successive criteria: their current frequency, the expected future frequency, the impact on their livelihood, and their farm's vulnerability to these changes. Vulnerability was defined as their difficulty to respond effectively to these changes. In phase 4, farmers focused on identifying primary adaptation strategies. Just like before, strategies were grouped into categories and given new agreed-upon labels. Finally, in phase 5, participants ranked these adaptation strategies in terms of how likely they were to implement them in the future. Back at the desk, we analyzed the collected information. Indeed, participants provided a variety of rankings for key items, demonstrating significant difference in opinions. To synthesize these individual perspectives into a group view, we implemented a method known as the border count. Here is how the border count works. For each item, we give a score based on its position in each participant's ranking. If an item is ranked first out of 5, it receives 5 points. A second place gets 4 points, and so on, with the last place item receiving just 1 point. We then add these points across all participants to determine the group ranking. The items that accumulate the highest total points are considered the most important according to the group's collective opinion. This method ensures that every participant's voice is heard and contributes to the final result. In particular, the border count will favor items that are broadly acceptable to a majority rather than those who are highly favored by a smaller group. As an example, we will comment one of the results obtained. In one of the group, participants identified 4 emerging changes in the climatic conditions. It corresponded to more extreme events. The label "strong sun" indicated prolonged event of extreme heat, literally burning the plants. The label "unpredictable rains" indicated a change of rain patterns from the traditional short and long rainy season traditionally found in the region. These changes makes it difficult to plan farming activities and increasing risk of crop failure. In particular, farmers were much more uncertain about what crop to grow in the next season and when to plant them. The label low rains indicated unusually long period of drought. The label frost indicated periods of frost at unusual time of the year. From the border count, we can extract two types of information. First, we can observe the diversity of the ranking among participants. For example, the distribution of the ranking for the strong sun attribute showed a consensus about strong impact and strong vulnerability. By contrast, there is a much higher diversity of views about the frequencies of these events in the future. Then we can analyze the group rankings. Adding ranking of all the respondents and scaling the results, we created a composite score that factored frequency, impact, and vulnerability. We obtained a clear ranking about the importance of strong sun events. While the other events are considered as more frequent in the future, farmers tend to see strong sun events as more harmful to their activities and seem to leave them without solutions. This concludes our video on using focus group meetings to understand farmers' views on climate change. We hope you are more convinced that these meetings are powerful tools for capturing diverse perspectives and deciding which future climate conditions should be used for our contingent behavior surveys.